In the city of Issaquah, our first clue that something was amiss was when EPA asked a number of water systems throughout the country to test for PFAS. Issaquah participated in that, and they got some pretty high results. PFAS stands for per and polyfluoroalkyl substances. They were developed to have certain chemical properties. They tend to coat surfaces, and so they can make things stain resistant, water repellent, and they do get used in products that we have around the home. They could be in your stain resistant carpeting. They've been put in fast food packaging. They've been put in cosmetics. We're concerned about PFAS for a number of different reasons. They're toxic, they bioaccumulate in plants and animals, and they're persistent in the environment. We interviewed firefighters working currently and also former retired firefighters. Fire departments all around the country were using AFFF, that's aqueous film forming foam. It's made out of PFAS, and they were being assured that it was safe. And so we found out there were a number of different locations where they trained. They trained a lot at Eastside Fire and Rescue Headquarters, and that seems to be one of the most heavily contaminated areas. But they also trained at Issaquah Valley Elementary School, Dodfields Park, which is right next door to the school, and Memorial Field, and a section of Rainier Trail. And we found out that there was PFAS hanging around in the soil at every one of these locations, even though they stopped using it several years ago. Some of the molecules of PFAS stick to the soil particles. Some of them get dissolved in the rainfall, and they wash with the rainfall down into the groundwater. It's important to know that the city of Issaquah and Sammamish Plateau both get their drinking water from wells in the Lower Issaquah Valley. And several of these wells have been impacted by these PFAS plumes in the groundwater. But in both water systems, both utilities use a variety of approaches: treatment, taking a well offline, buying water from another source to make sure that clean water is going to the taps. The whole cleanup process takes time. It takes a while for us to understand the problem, to get our hands around the entire extent of the problem. Yes, we want to make this happen quickly, but we don't want to rush it too much, because if we don't get that first step right, then we're doing some kind of cleanup that doesn't actually address the problem because we didn't understand the problem correctly to begin with. So during our remedial investigation for Eastside Fire and Rescue Headquarters, we tested one technology that we might be able to use to clean up the site. It's called a permeable reactive barrier. It's about a 10 or 15 foot wide path that goes along here. I think it's about 20 or 30 feet long. It's full of colloidal activated carbon, and so as the groundwater flows through this area, this carbon, it acts just like a filter. It grabs the PFAS out of the groundwater. The groundwater continues without the PFAS. We have a monitoring well right here, which shows what the groundwater looks like as it's coming out of the permeable reactive barrier, and it's really clean. We've got a lot more work to do in this area, so we'll just keep coming back and checking it regularly. If this permeable reactive barrier becomes the final remedy, then we would probably expand it in this direction, and we'd also wrap it around and get another side of the property. We would be leaving some contamination in place in the ground, which means we will have to monitor it for as long as it stays there. We want to get the contamination out of the environment because we want it to stay healthy. Eventually, it would be nice if we could turn off all of these treatment systems because we got all the PFAS out of the water.